Hello, everyone. Thanks for coming. My name is Asad Khan. From the product side, I run the SQL Server business and the SQL services that we run in the cloud. It's really a pleasure for me to talk to you about the new innovations that we are bringing in SQL. As I was preparing for this presentation, I was both excited and a little bit worried. I was excited because there is so much innovation that we have brought in SQL Server. It's not only limited to running it on the server, all the way from the edge to the cloud. But I was worried because there is so much content that I want to go and cover, and I hope I do the justice. SQL Server has been an amazing success, both in terms of commercially. Today, if you go and look at it, 98 of the top 100 Fortune companies run SQL Server. SQL Server has the most deployed database per unit in the world. And this innovation is not limited only to running it on-prem. Even in the cloud, SQL Servers, which is the PaaS service that we run, is by far the biggest service that we have in Azure. So then the question becomes, how do we keep innovating in SQL Server? Because we live in a time where we are seeing disruption at an exponential rate. And if we don't understand the customer scenarios, if we don't understand how companies are doing innovation and modernizing their data platforms, we will miss the innovation curve. Today, the data is being generated at an exponential rate, and we have all seen that. And as I, in my current role, work with hundreds of big enterprises out there, one pattern which I continuously see is that people are trying to break the silos that exist today. And by that, I mean that whether you are looking at your employees' data, whether you are looking at your customer data, whether you are looking at the operations or products, that data cannot live in silos. They have to continuously flow, integrate, so you can build intelligent application on top of that. And it is only not limited to the type of data, but also where you collect that data. All the way, whether it is on the edge, whether it is running in the servers, whether it is running in the cloud, or whether you are in the hybrid platforms. So rather than going into the details of each one of those, I decided, why don't I take a real example, a customer we have been working very closely, and then show how they are using the SQL products. Throughout this presentation, every scenario and every demo I will go and do is only done on SQL Server. So Zeiss is a German company. They are one of the biggest companies when it comes to manufacturing of the optical systems and optoelectronics. What that means is that they have factory floors. They produce a lot of lenses and other hardware, which is cut to the precision. And they have to continuously monitor how their factory floors are operating. So let me switch to my computer and actually show you an example of the application that they go and run. So what you see over here is that this is the simulation of their factory floor. And then you see that they have multiple of these manufacturing pipelines where the lenses are being built. So we will go and focus on one of these. And as you can go and see, in their case, what they have done is that a few months back, when we went and launched a SQL Server running on the edge, they worked very closely with us, and they have deployed SQL running on the edge. And as you can see, that on their factory floor, as the devices are being built, they have multiple of these machines. Some are for grinder, for finisher, and for the lens coating. And for them, the key requirement they had was the data has to be not only stored, but also the machine learning that they run on top of it has to be right where the data is. So for this demo, let me take an example where we took a SQL running on the edge, and we go and deploy it on the machine. And this uses the integration between the SQL on the edge and the IoT for the device management. And once this is deployed, as the lens comes through, and if there is any anomaly which is detected, it automatically fires an alert. And now if I go to that warning, the key thing you will notice is that it has already captured every bit of that data which it captured as the lenses were flowing through. Not only for this one, but all the other lenses that were manufactured. So they can see the trend, and they can see where the anomaly is happening. Today, you can go and do the same things with any sensor, but the problem is that you have to stream all of that data either to the hub or directly to the cloud. Even when you don't need that data, with a powerful platform like SQL Server running on the edge in small devices, what you can do is like you can continuously capture every information. You can deploy a machine learning model right there, and then you can raise warnings and only flow the information that you need when the warning happens to the hub or to the cloud. And I have some of these devices that I brought here. These are the examples where you have the full SQL Server running on these devices. And these are the similar devices that they are running in the factory floors. The next thing is that even if I have the machine learning model deployed, the question becomes, how do I even get that machine learning model built in the first place? And also, the data coming from a single device may not give me the full picture of what is happening on my factory floor. So what they have done is that they are using the latest innovation in SQL Server 2019, which is the big data clusters, which comes with HDFS, which is your enterprise data lake, and it comes with Apache Spark. And they are streaming data from all of these edge devices, which is running SQL Server on the edge, and then moving it into the enterprise data lake on SQL Server 2019. And now they are able to go and analyze the data across all the devices that they are manufacturing. Let me quickly show you the code behind this application that I just showed you. So what I have over here is that this is the Azure Data Studio. I don't know how many people have seen it or worked with it. Can I see a show of hands? Great. So our intent is that we wanted to build a really modern tool for data developers, DBAs, and data scientists. And again, we are on a journey where we are doing really deep integrations between SQL Server Management Studio and Azure Data Studio so that it is not one or the other, but people can use the power of both of them together. So over here, I have connected to the SQL Server 2019, which is running in the big data mode. And I am also connecting to one of the edge devices that showed the warning when I showed the application earlier. So if I go to the notebook which we created earlier for this demo, what you can see is that I import some libraries. Once I have done that, this is the part where I'm collecting data from all the devices. And as the data come in, then I go and do the any changes which I want to go and do in the data, whether it is the data types or whether it is the columns which I'm interested in. And once I do that, this data is readily available not only for Spark, it is also available in SQL. So any unstructured data, now that you are collecting in SQL Server 2019, can be accessed both from SQL as well as from Spark. And this is a very powerful concept. Every customers that we have worked with, this is the thing which is exciting them, because it is breaking the chasm that exists today when you go to any company and talk about whether they are working on the big data systems or whether they are working on operational databases. So for this one, what I will go and do is, like, if you go to the databases, you will see the one which is the grinding finisher, where the error happened. And I have moved that data now into SQL Server. Before I do that, let me show you one thing, which is that this is the HDFS storage where all the raw data was landing. And from the factory floor, these are the files which were coming in. So these were coming in as CSV file. And now if you go and right-click, you can go and preview that data. And what you will see is that this is all the data that was being generated on the SQL Server at the edge, and then we were streaming it for our analytics. So now I will go and query not only this data, but the data which I have combined from all of them together, and which is now accessible through SQL. So I will do right-click. Rather than the top 1,000, I can go and do the select star. And as I run this query, again, this query is going directly against the unstructured data, which is combined across multiple sensors. And now I can go and start analyzing this data and start building machine learning models. But even before that, like me as a data scientist, I need to know which are the features or the columns which are interesting to me, which I need to take into account as I go and build the machine learning model. So now Azure Data Studio comes with visualization built in, and this is the work that we have done in close collaboration with the Microsoft research. So the difference between this visualization and the other visualization that you typically see is that this is showing every data point that I have for the data which I landed. So now I can go and click it and go at any level of detail. So for this analysis, what I will go and do is, let me make more space here. And let me go to the scatter chart over here. And then on the x-axis, I will keep the cooling efficiency. On the y, let's go the cooling power. And then what I will go and do is that I will color it by the machine efficiency. So now what I see is that there is some correlation between the cooling efficiency, the cooling power, but I see some red on the left side, which means I need to go and look at another dimension, because right now both red and green exist together. So there is something which is affecting as well. So now what I can go and do is that I can go to a 3D model and pick another axis. And let's say in this case it is the vibrations. And now I have a 3D model which I can go and look at from multiple sides. And again, just to recap, I started from SQL Server running on the edge. I was able to collect data right where it is being produced. I was able to bring data from multiple of the edge into a big data cluster running 2019. From there, I just connected through my Azure Data Studio, and I ran Spark as well as I'm running SQL queries. And now I can go and understand how to build the machine learning models for this data set. So going back to the notebook, now here we are, and now what I will do is that I will start doing picking the right algorithm for building the machine learning model. And once I have it, and in this case, I'm using the random forest classifier, I can go and start building the model. But not only that, one thing which people go and do, and again, like I don't know how many people are the data scientists in the audience, is that it's not a one-time thing that you go and build a model. You have to retrain the model every time. And as the model drifts, as you get more information from the manufacturing or whichever the scenario is, then you have to continuously retrain as you're getting more data. So, and one of the common platforms which is being used out there is MLflow, because now even the management of those models is not easy enough. Now, as we were working on this project, the question became we don't want to just solve part of the problem. We need to build this as a full platform for data scientists. So we have done integration with MLflow, and what it means is that every model that we are building, it can not only be used with MLflow, but we change the backend of MLflow to be a SQL Server. And we have worked closely with our research team. Now this is pushed into the open source. Now MLflow is backed by SQL Server as an additional option. So what that means is that if I go to my databases, you will see another one which says MLflow, and I am storing all my models over there. And I can actually right-click and just query the models that I'm building, just like it is any other SQL Server table. And now you can see all the models that I have built. And this is just amazing, not because now it gives you a single platform where you are doing all the scenarios. It is also amazing that people now started to see the value SQL is bringing over here, because now you can apply every security configuration, whether it is data masking or any other thing, because now all the models are being stored in an enterprise-grade database. So let me continue on the flow for building the model. As I have built the model, I can look at the accuracy, and then I convert it into ONNX format. And again, ONNX is now a very common open source interchangeable format, because now you can build models no matter which platform, but you can convert it into ONNX so you can run it everywhere. And once I convert it into Onyx, then I go and deploy it into the SQL Edge. And again, over here, at the very end, you will see that I pick one of the edge devices, and I target that one, and I go and deploy over there. And once I have done that, I will go and now connect to my edge. And over there, as I said, I have connected to one of my edge devices here. And this is just like any other SQL Server, because this is not any other specific version or downside SQL Server. It is the full SQL Server, which means I can use the same tools that I use to connect to my SQL. And now I have the notebook. Let me just close this one. And this is the notebook which is connected to my SQL Server. The first thing I can go and do is that I can run a query on the classification of the models that I have done. And what it means is that if the value is 130, then it is the optimal pressure. If it is 115, 100, and 90, and at 90, I know that the things are getting bad, and I need to go and take some preemptive measure. So now what I will go and do is that I can go and query all the data which is stored on the edge. So this is showing me all the data, and again, as you can see, the columns and the rows, which is based on the time. And once I have done that, I can run the predict, and this is where I'm using the machine learning model that I deployed against the data which is being stored in the edge. And again, for this demo, this is happening as a batch. In the actual factory floor, this happens at a real time. Once I have done that, I will take one of the examples, and I will say, do a query, which is the join query between this and the classification I gave you, that if it hits a certain limit, then there is an issue. And now you see that for ID 28, it is saying the value is 90, and the message is there is a failure condition. And this is the failure warning that I showed you earlier when I opened the Zeiss application. So again, to recap, we have worked with them, deploying the edge devices, flowing all of that information into 2019 Big Data Cluster, and then I showed you how we build the model based on all the data we are collecting and then deploying it on the edge. If you can go back to the slides. So again, this is just the two slides are just a recap. SQL Server Edge deployed on the factory floors. And these are the key features that we have brought on the edge. So the other key thing we will see is that although we are bringing the same SQL Server engine in multiple form factors and platforms, but we are also enhancing it for the specific scenario that we want to target for that customer base. So SQL Server Edge, it works on ARM, it works on Intel, it works on Windows, Linux. We are working on Android. It has a time series built in for the data which is in motion. It has support for deploying models which are in Onyx. And again, there is a single deployment management through IoT Hub. Or we are also working with OEMs and ODMs who are doing their custom solutions. And again, this is the same SQL come with the unparalleled security promise that we have. The next thing that which I showed you was that as the data is being collected on the edge devices, we move it into the big data cluster, and then from there you can do the processing. And this is SQL 2019. It has a lot of new features. Some of that I will cover later in this presentation. But the one which we really used for the previous scenario was the big data capability. And again, this is a very crowded slide, too much information there. But just to summarize, what we have done is that if you look at the bottom, you have HDFS, which is your enterprise data lake for your unstructured and structured data. You can drop all your data of any size over there. And once you do that, now we offer two query processing engines. We offer Spark and we offer SQL. And they are going against the same store, which means you can go from one side and do some modification and then read it from the other side. So again, the idea that we had was that we don't want to just ship Spark as an offering. What we wanted to do is bring Spark closer to the SQL customer base and says like, now you can use the power of Spark inside SQL. Then the things which I did not go into the detail, we have in 2019 full data virtualization capability, which means that if your data is not sitting in SQL or in this HDFS, you can go and query data outside of the cluster as well, and it will show up as an external table, which means from all practical purposes for SQL, it's just a table, and you can just do query on top of that using T-SQL. I have also listed some of the deep dive sessions that we have because I won't be able to cover everything in detail. So here are some sessions, and again, on other slides also, I have listed the sessions which I will really encourage you to go. So in a sense, if you go and look at it, a SQL Server which was built to run on servers, we take the same engine, and now we make it available to run on the edge. Moving on the journey, let me go and talk about some of the key enhancements that we have done on the engine itself. The first one is the security. And again, security is paramount for us. Right now, if you look in the cloud, SQL Server has some of the biggest and financial institutes which have stored their data, and they're running their mission-critical application. And same is with healthcare and any other vertical where security is important. The few I will go and highlight as the important one. The first is that we have now made the security features available in the standard edition, because for us, this is the table stakes. Like security is not one where you choose or you don't choose. So whether you are using enterprise or standard, the features are available. The second one is that we have shipped the feature for hardware enclaves because always encrypted is used by the customers, but right now there is performance issues because the data has to move to the client for decryption. And now with hardware enclaves, it happens right on the machine itself. And there are many other features that we have built, and as I said, like we will go and cover in more detailed session. The second one I will go and talk about it is on the performance. I have 2 slides. The key one, the takeaway from this one is that the investment that we have done in the persistent memory, which like practically removes the I/O stack when reading data when it is being read from the persistent memory. So huge improvement with no change as long as you are on the hardware which supports persistent memory. Then when it comes to the availability, the one key takeaway from this one I will say is the accelerated data recovery. It has like the number of customers we have worked and who have seen a huge change in terms of for unplanned failovers or long-running transactions and doing the rollbacks, they have seen a huge difference. And again, the advantage that we have is that we have the same engine that we run both in the cloud and that we ship on-prem. We already launched this capability in the cloud, and today more than 5 million databases that we run in the cloud are all using the accelerated data recovery. That enabled us to actually go and give an SLA, which is financially backed for the availability of SQL databases. And Azure is the only place, and SQL is the only database engine which gives you financially backed SLA in the cloud for availability time. So in one of the companies we worked very closely actually is Itaú, which is one of the largest banks in Brazil. And it is actually the 10th largest bank in the world. And I'm really fortunate that Augusto, who's their general manager of IT, and Eddie, they were so excited that they agreed to fly here in person and join me to have a quick conversation in terms of the journey that they saw as they migrated and upgraded their systems to 2019. So please welcome Augusto and Eddie. Hey, how are you?
How are you?
Hey, man.
Hello, everybody.
So, so tell me about, like, I know, like, Itaú Unibanco is one of the largest bank. Like, what do you do, and what is the market you are in?
Yes, like you mentioned, we are the largest bank in Brazil, and we operate in the finance and the insurance industry. Our customers use our services like other banks. And we need to rely on risk analysis to make decisions on new transactions and ongoing transactions. This is a critical component in our financial process.
That's great. So I know that you have been growing a lot over the last few years. Like, what kind of challenges did your data infrastructure face?
Yes, we are growing in number of customers, having more application and process. And because of that, you have more data than ever. Our concern is that our infrastructure would not keep up with our growth. And this would affect our SLA to the business.
And a good example is when we have to hold back an operation. And it took a long time and would become a problem of other workloads as well. And we need to be able to run several operations at the same time.
That's great. So what were the most important new features or improvement in SQL that helped you make the decision to upgrade to SQL Server 2019?
There were a few of them. First of all, we knew that the application we chose used a query that had problem with performance. We wanted to see if the new intelligent query processing would improve the performance of applications and data processing. We validated by executing DEA and proved it would be valuable.
That's great. So can you tell me a little bit about the upgrade journey itself to 2019?
Sure. We deployed SQL Server 2019 and side by side and migrated the databases. We immediately saw performance improvements for the application.
This is great. So did you have to make any changes to your application?
Oh, no, this is a great question. And always code changes in the applications have high cost and risk. And we could make the existing code faster without almost no code changes. In fact, over 90% of the queries run faster compared to SQL 28.
That's awesome. So the intelligent query processing in SQL 2019 really improved the performance, as you said. So all you had to do was change the compatibility level to just 150, which is the latest one?
Yes, that's correct.
Awesome. So did you, like as I mentioned earlier in my presentation, the accelerated data recovery, can you tell us, like, did you use that and what is the results that you found?
Yes. We have several business critical databases that are long-running transactions. One of the challenges we had was the longer recovery process of our databases when we had to cancel transactions.
So I heard that sometimes the recovery took as long as 40 hours.
Yes, this is a real case. But on average, it took 4 to 5 hours to do a rollback. With accelerated database recovery, rollback time dropped to a matter of seconds.
Wow. This is great to hear. I'm sure we have a lot of customers in the audience who have similar concerns in terms of the application performance and long-running recovery times. How do you feel about SQL 2019 and its importance to your business?
We are really happy with SQL Server 2019. We think it has improved our productivity. We also think that we can now provide better solutions for our customer. We feel safer and confident.
Thank you very much. So how do you feel about partnering with Microsoft, and what kind of the future plans you have for leveraging Microsoft technologies?
Microsoft is a great partner that has been providing new technology to help Itaú Unibanco be our customer's digital bank.
We also use Office 365 and SharePoint and OneNote in Itaú to improve our productivity and team collaboration. We are planning to switch to Teams in the near future.
We are always looking at new Microsoft technologies to help us to deliver on our mission to enable the people's power of transformation.
Thank you very much. Thanks, Augusto, and thanks for Andy. Really glad to have you here on Us With Stage.
Yeah.
Thank you.
Bye-bye.
So the next one, the demo that I'm going to show you, this is one of my favorites. And again, like all the demos that I'm showing you is running on the latest bits. So if they work, clap. And if they don't work, clap harder. So let me switch back to my machine, which actually went to sleep. Just. So what we have over here is that we worked with Lenovo, and they have this machine, which is the 8-socket machine, has 224 processor. With hyper-threading, it gives you 448. And then we challenged ourselves to go and see what is the limit we can go and hit. One single machine, and we have 150 terabyte sitting over there. And we have 1 trillion rows stored in there. And we took a standard TPCH query that we ran. And this is I just connected remote desktop into that machine. And if you go and notice over here that, and this shows the power of how SQL make the utilization for the compute power that you have, you will see all of these cores being used at 100%. And this was just amazing in terms of if you go and see whether it is any other database, whether you look at any other big data system, they are not able to use and extract the power that SQL can go and use, even at that limits. So this query itself, we have run it multiple times. And again, this is on a warm cache. It takes close to 93 seconds to 100 seconds, so I can keep it running. But what you will see is that the end result is that this is a TPCH query. It goes and processes all the trillion rows that we have in there and gives you the result. And this is totally amazing. And one other announcement that I will go and do is that this past weekend, Cisco finally listed that on TPCH, 30 terabyte, now SQL Server 2019 is the world leader. So if you go to the TPH site, it will be listed as the top leader. So I will come back to this one. It just takes a few more seconds to go and finish the query. Let's switch back to the slides for now. Actually, the query just came back. Sorry, if you can go back. Yep, so what you see over here is that it took 1 minute, 38 seconds. You have trillion rows that we processed. This is the query, and we will go and publish all of this externally. And this is the power of SQL Server 2019 with intelligent query processing and all other improvements that we have done in the performance. OK, let's switch back to the slides. OK, so let's shift a little bit. Like as I said, like the key thing for me for this session was that show you the enhancements that we have done in SQL, not only the box, but the edge, but all other platforms where we offer SQL. So let's go into the cloud for a while. And then in the cloud, we have multiple SQL Server offerings. On the left, you will see that we have the SQL that you can go and run it on a VM. And this is like you are taking the advantage of Azure as a platform, and then you can go and pick and choose any version of the database that you can go and run over there. Now, over time, we have done a lot of improvements over there. Now we have a control plane in the cloud, where you can go and come and then pick your hardware, pick your SQL Server version, and then we go and run it for you. Not only that, we continuously bring new features, like we recently launched Azure Threat Detection, monitoring, HADR, all of those capabilities are available. So even for customers who are not going and building and taking a bet on our PaaS services, this is a wonderful option to go and run SQL Server in Azure. Then we have the managed instance. I don't know how many people know about the managed instance. Can I see show of hands? So in essence, managed instance, the goal we had was how can we bring the full SQL Server parity running in the cloud as a managed service for which we give you financially backed SLA. And that is the work that we have delivered through managed instance. We have a lot of customers who are now migrating with one click using the migration service and moving their databases into the cloud. With no downtime, this is all online migration. Then the rightmost, we have the SQL DB. Most of the people who are using this is building new cloud application, making the power of things like Hyperscale and serverless that we have brought in. And this is where we are continuously bring innovation, but the idea is that we bring that innovation to all our portfolio that we have in the cloud. So as I mentioned, one of the key innovation that we have done in the past few years is Hyperscale. And Hyperscale is amazing just because it uses the SQL engine, but we have totally re-architected how we go and run this thing. So just like I was showing you the trillion queries demo, where we had to be confined to a single machine, now you are not confined to any size of data. Today we have tested it at 200 terabyte. But again, you can go above 200 terabyte. There is no design issue or limitation when it comes to the size of the data. And also on top of that, you can go and scale out as many number of the read replicas that you need. So you can go and both scale out at the compute level as well as the storage level. And let me quickly switch to my machine and show you a quick demo. So what we did was that for this demo, we took the data that we had coming from the sensors for Zeiss and push it into the cloud. And again, the scenario over here is that as you are collecting data, some of the unstructured data you want to be available in a single database so that you can query it, you can share with your ISVs and other partners that need access to that data for the inventory and other purposes. So what we did was that we have two parallel pipelines of data which is streaming. The first pipeline put that data in the SQL DB, which has an attached disk, which has a size of 4 terabyte. And what you will see is that as soon as it hits the 4 terabyte limit, then obviously you cannot go and store more data. The second pipeline of the same streaming data is being sent to Hyperscale. And over there, it is also sitting at 4 terabyte, but now you are not limited to any size. So for this one, like on the top bar, it shows you the number of the sensors simulated that we have, which are pushing the data. Now I can go and take it from 1,000 to 1,000,000 devices, and obviously they will slowly come up, which shows you on the second number, which is like now 83,000 are online. But now we are not limited. I can take data from one factory floor, multiple factory floors all around the world, and all of that data can land in a single SQL Server database with no upper limit in how much data I can go and store. And again, this is the power of the Hyperscale. And let me go to the portal and show you that this is the backing Hyperscale database that we on which the data is landing. And as you can see that we left it running for a long while before coming here, and now it has over 200 terabyte sitting in this Hyperscale. And now I can also go to configure, and I can go and say the number of the replicas I need. So right now it is sitting at 2. I can take it from 2 replicas to 30 replicas. And again, if each replica has 80 cores, you can see the number of the cores which are available for you for your compute power. The one more demo that I wanted to show, which is not directly related to Hyperscale. Let me just connect. OK, let's wait for 1 minute. Maybe if you can go back to the slides, I will come back to this one. So the other demo that I will come back as I connect to the remote machines, because as I said, like we have set up these databases on multiple machines, and I connect to those, is that use of the accelerated data recovery on SQL Server. And in this case, we chose to use Hyperscale. But again, that feature is available anywhere. So I will come back to that demo. But going forward, so the other key innovation that we have done is SQL Serverless. And the key thing for SQL Serverless is 2 parts. One is when the query is not running, we don't charge you for the SQL bill. And what that means is that you don't have to worry how much you are paying and how much of the course you need. The second key thing where people are using this capability is the elasticity and letting us decide how much core and memory you need, and which is very, very powerful. So you can go and today go and create SQL Serverless. You can say my range is from half a core to, let's say, 16 cores. And from there on, we will look at your application and the pattern at which the queries are coming and how many of them are coming. And we will scale you up and down to give you the best performance for your queries and your application. And if there is no query running, we will take away both the storage and the memory so that you are not billed for anything. Your data stays in the remote store, which is one of the cheapest places to store your data, but you are not paying for any compute, storage, or for the SQL IP. And today, after we launched this thing, we have over 3,000 customers who are actively using many databases in the serverless form factor. And today, we are also announcing the general availability of serverless. So now we have the SLAs, which you can go and use for when you run your application on the serverless. So I have a quick, if you can switch back to my machine. So what I have over here is that I have connected to the portal, which is showing the serverless. And you see 2 graphs. And it becomes clear if I show it on, let's say, the last 7 days. So on the top, it is showing you the compute utilization. So this is where when the query came, and as more queries were running, you can see that we were using more of the CPU. The bottom shows my bill. And as you can see, that when I'm in the paused phase, I have 0 bill which is being generated. And so it completely follows the pattern of your application. And we have machine learning, which we have built in, where it detects what is the right time for us to take the storage and compute away. Because especially taking the storage away is an important decision, because then you have to cache the data again for the performance reasons. So we have a machine learning capability which looks at every application pattern and decide when is the time we should take the resources away and give you the best price performance for your application. So I will show you let me see if my other machine came back. So what I have over here is, so this is the accelerated data recovery demo. What I have is I have connected to 2 databases. And if you go and see the one on the left, and if I run this query, you will see that I have 20 billion rows over here, and I have disabled the accelerated data recovery. If I go to the other one, what you will see is that same data, 20 billion, and the hyperscale is enabled. Now let me run a query. And this query is a very simple query, but what you will notice is that where the DBA forgot to add the where clause, so it is going and updating all 20 billion rows. And again, this happens where you have a long-running transaction, and then you made a mistake. But now if you go back and cancel this transaction, it will take a long time for it to roll back. And this is where Augusto and Eddie were saying that they had some of these issues in their environment where the rollback was taking a long time. So in this case, what I will go and do is that now let me go and cancel this one. And I will go and cancel this one. And what you see is that if you look at the bottom, this is canceling query, and it will stay there for a long time. And this query got canceled the moment I hit cancel, because the rollback for this one happened instantaneously with the accelerated data recovery. So let's switch back to the slides, please. So the other thing is that as so many organizations are looking for either migrating their databases or building new applications or being in the hybrid state, one of the key things is like, what is the cost? Because again, when you have a large data state and you're using a lot of relational databases, there is a lot of cost that is associated. So we did this study with an independent company, GigaHome, and what they looked at was that what is the cost that the customer has to pay as they migrate from on-prem to the cloud, both for Azure as well as for Amazon. And again, this is both using SQL Server. And on the left chart, what you will see is that without even applying your AHub benefits, you get a 40% saving when you run your SQL Server in Azure. But on the right, you see that this is 86% saving when you apply AHub and RI. How many people know about the AHub benefit? So very few. So again, we have not done the good job. So AHub is the program where anybody, any enterprise who have the license and the software assurance, when they come to Azure, they don't have to pay for that number of cores when they run their SQL. So if you go to any SQL flavor that I showed earlier, there is a checkbox which says, I have software assurance for SQL, and if you check that box, we turn off all SQL meters. So you are paying a little bit for the manageability and the compute that Azure charges, but there is no charge for SQL. At that point, you are running the cheapest database in the world because you are not being charged at all. Now you can go and run cheaper than whether you are running open source, whether you are running any other database, whether in Azure or outside. SQL provides you the cheapest option to run SQL Server. And as I mentioned in the start of the presentation, the good thing is that we have so many customers out there who have taken a bet over the years for SQL. And now they come to the cloud and they can use the money for which they paid for the SQL software assurance. And this one is the other one which talks about that overall also, all the other places you can go and save the cost. This is an example where if any organization out there which is running SQL 2008, which went out of the support, and then you have to buy very expensive yearly support contract, you can take the same servers, don't even move it into the PaaS, just move it and run it in Azure using Azure as the infrastructure. And now you can go and not have to pay for any of the security patches. You don't have to pay for any of the extended support. So this is again a huge benefit that you can only get in Azure. The other one, which is not listed here, but we recently announced, is that if you have SQL, we extended or provided more flexibility for HADR benefit, where earlier, if you are running a primary, you can have a secondary, which is your HA, free. But now we also allow a second one, which is your DR, which is the async replica, for free. And if you are running on-prem, we allow you a third one to run as a DR in Azure. So literally, this is a new benefit. Even if you have any existing SQL Server running on-prem and you want to have a DR solution, you can go and pick any of the 54 regions where we are available in the cloud and use that DR benefit for free of cost. So the other thing which I wanted to talk about is that we are seeing a huge momentum when it comes to the migrations. And we are helping hundreds of enterprises out there to migrate their data state into the cloud. And this is not just a lift and shift of the migration. This is like I can do a lift and shift, I can modernize, I can take advantage of other cloud data services that we have. And we have multiple of programs and dedicated resources that are helping with the enterprises. This is just one example, which is the Azure Migrate program, where we look at the number of the cores you have, and we will not only help you migrate, but we will also do a payout to your partner with whom you are working for your migration. So this is like you can get a financial benefit in terms of the migration and the work that your partner is doing. So the next is that I have a few slides that I am going to go and cover of some of the new features that we are bringing. This one is that for our SQL DB PaaS service, we are enabling two new hardware types. We have the F series, we have the M series. F series is for compute-intensive workloads. M series is 128 cores, 4 terabyte of memory. And you can run really intensive workloads on top of that and still be in the managed service and get the SLA. The other one is that I covered this earlier in the session, that we have invested heavily on the security. But again, when it comes to the cloud, there are other facets that we need to go and protect. And if you go and look on the left side, from the left to the right, we have the innovations that we have done in terms of the identity offerings that we support, the data protection, on the network side, monitoring, and then security management. All the items which are in the yellow are new, and we also partner with partners like Imperva and IBM Guardian to make sure that we offer options as the customer comes to the cloud. So in the cloud, you cannot get any better security when you run your databases than what we offer in Azure using SQL Server. So, and one of the great example that I wanted to share, where one of the company we worked very closely, who took advantage of the many of the features in the cloud that I just talked about, and were able to migrate their entire data state, is HRN Block. And again, people who are from the US, it's a very familiar name. And as you can expect, that security, online migration, no downtime, all were extremely important things for them to consider. And now, for this tax season, everybody who goes to HRN Block and file their taxes, all will be processed in Azure. They have migrated the entire data set into Azure successfully. So let me roll a video that shows, like it's a 1.5 minute video to show their journey.
HRN Block requires a highly resilient infrastructure.
Due to the seasonal nature of the tax business, we might have 5 times of workload requirement on the last day of the tax season.
This presents a tremendous opportunity for us to adopt a more effective elastic model. So we started moving aggressively into Azure.
As part of our data modernization initiative, we are trying to simplify our data stack. SQL Managed Instance was providing us the most seamless migration path to Azure.
The first phase was just lift and shift. We're reconfiguring our environment to move from an IaaS to a PaaS model so that we can really take advantage of cost savings around infrastructure and things that are going to now be automated.
Native integration of Azure Databricks reduces the operational complexities and gives us dynamic Spark capabilities for our analytics workload.
Investing in Azure Data Service and data platforms has really set up an amazing foundation to use AI and machine learning to better serve our client.
We're trying to iterate even quicker by implementing Azure DevOps processes. We have just started to implement CI/CD to deliver product functionality faster.
In 2019, we served almost 20 million tax returns running in Azure.
Migrating our platforms to Azure has really allowed us to deliver new products and services quicker.
It allows us to make our client experience better, which really at the end of the day is why H&R Block is here.
So again, going back, if you go and look at the journey, like we talked about the edge, we talked about the server, the innovations that we have brought in 2019, and then if you go and look at the cloud, same SQL Server engine bringing new capabilities across all these form factors. So the last thing I want to go and talk about is the experience of running SQL Server in the data center. And this was a huge announcement by the name of Azure Arc. So I want to spend a few minutes in terms of what have we done over there. So as you know, in Azure Arc, one of the key things that we are bringing on-prem is the managed data services that you can go and run now in your own data center on your own infrastructure. And one of the service that we are bringing over there is Azure SQL Database. And the journey that we started for this one is, as we were working with the customers, the question was that we did this big change where we take the same SQL Server engine and then we offer it on-prem. But the thing is that we don't bring the whole platform, which means that over the years, as we did the innovation in the cloud to manage millions of databases, we don't go and hire the IT people and the people who manage their database at the same linear scale as the databases are growing. We have a small team that can go and manage millions of database, and whether from 5 million we go to 10 million, the size of the team that is managing it doesn't go up. And the reason is that there is a lot of innovation that has happened on the manageability, which is outside of the engine itself. When you come to the cloud, how can we go and deploy database in minutes? When we go and deploy the database for you, we give you the SLA because right away we have a primary and we can run 2 or 3 secondaries. When the database goes down, you don't have to go and do that thing. We don't have to do anything. We automatically detect that the failover has to happen, and we give you the same connection string now working against the other database. When there is a disaster in a region, we can use the auto DR capability to do an automatic failover from one data center to the other. Now the thing is that for many of you who have been running SQL, none of that is new. You do it on-prem. But the thing is, you do it. And the question was, how can we bring the IP that we have done for you and make it available so you don't have to do all this work? And that was just one part. There are many things which we offer in the cloud which are not available on-prem at all. And one example is that the always current. What if I can get a SQL version which is always current, which automatically stays up to date, but at the same time give me the guarantee that my application will not break? Because imagine that in the cloud, on daily or on weekly basis, when we push update, we push that update to more than 5 million databases. And all the applications that are running on top of that, they don't even know that we pushed an update, because we guarantee that nothing is going to break. So the idea was that how do we go and bring that capability on-prem? The other example is elasticity. If I'm running it on an 8 cores, how can I go and run it on 16 cores? Or how can I shrink it down? And then also, please charge me based on what I'm using. Don't charge me on the number of cores that I had to decide 3 years in advance. So that was the idea that we brought with Azure Arc. And databases is just one part of it. We offer the services for managing your infrastructure, for your Kubernetes environment. But independent of all of that, you can go and use Azure Arc for only running your data services. And the only thing we ask is that we take a bet on containers and Kubernetes for your orchestration. On top of that, we will layer the same cloud platform that we run in public Azure now in your own data centers. And with that capability, you can go and build applications as if you are running in the cloud. The other, and let me quickly show you the architecture. If you go and look at the bottom, again, any hardware, any environment, you can be running on an OEM. You can run it even on Azure Stack, Google, Amazon, or you can even try it out running in AKS, running in the public cloud. And on top of that, we will go and we are working with the partners to certify multiple of the Kubernetes distribution that we will go and certify that it runs on top of that. We will test it. We will make sure we have the debugging material, the support system around it. And then on top of that, we offer you a unified manageability. And what I mean by that is that we offer both scenarios. So we offer where you can go and run it in a disconnected manner. At that point, you have limited or no connectivity to the cloud, and you are running in your own data center. And think of it as an extended region, but it's totally closed. And the other one is that you can also choose to have it fully connected to the cloud. When it is fully connected to the cloud, you will see that some of the demos that we showed in Satya's keynote and other keynotes is that now you can go to the Azure portal, and then you can go and deploy and manage from there. But working with the SQL community for so long, we recognize that disconnected is also a very key scenario for the customer base. So as a result, we have done all the work to make sure that it works the same when it is disconnected. And what that means is that at that point, you don't even have the access to the Azure portal. So we are building the full portal experience in Azure Data Studio. So you can go to Azure Data Studio. You can choose the database you want to go and deploy. It gets deployed. You can choose the number of the replicas you need or the DR capability that you want to go and enable. You can define the security and the policies. And from there on, it will run in a disconnected. If you are connected, then you get other advantages. You can go and buy Azure Threat Detection. You can buy into the OMS for monitoring. You can buy into other services. So now you have your data stays here. You take advantage of the cloud for these additional services and the common manageability. And on top of that, when you ever decide to migrate, now there is even less work because your application is already running on the same platform now where it is moving to. And from your IT perspective, you have already educated your people and yourself to work in that environment. So that is the advantage that we go and see with this hybrid play. Again, like this is a platform play, how to bring the cloud services on-prem. We will continue to invest in the SQL engine itself because, as I showed, engine stays the same even when we run today in the cloud. To summarize, if you go and see the reason we called this session as from the ground to the cloud is that if you, over the years, see the innovation and the investments that we have made in SQL, it ranges all the way from the edge, same SQL Server database running in the server, in the hybrid platform, which is the Arc, and running in the public cloud. And although we run the same engine, but we don't take just the common denominator and make it available. We have done the work to make sure that we have features that are specific for that environment and that customer scenarios that we go and offer for each of these offerings, whether it is on the edge, then time series is important, running on the ARM is important. When it comes to the SQL, then there are other requirements that we have similarly for Arc and for the cloud. But it is the same SQL Server engine that we go and build once, and we deploy it everywhere, and then we enhance the things around that. So that is our vision for SQL, and we will continue to invest. We really appreciate all the feedback and all the love that we get from the SQL community. Like, SQL is lucky to have such a strong community. If you go and see the number of the people, thousands of people every year who attend SQL Saturdays. If you go and look at the past community, probably the largest community-driven events which are associated with a single product. It is truly impressive, and that is one of the reasons that SQL stays relevant and continues to grow, both on whether it's outside the cloud or in the cloud. So thank you very much for your time. We love your feedback. Give us your feedback, and we hope to continue to grow the SQL business. Thank you very much. These are some of the action items which are listed in the end, which talks about like the launch of the suite in the cloud, talk about how to install 2019, the edge, and then you can go and register the new RP that we have built in the cloud as well. Okay, thanks again.